One of the special kinds of sequences that we're studying in this chapter is an arithmetic sequence. And an arithmetic sequence is just a sequence of numbers where I'm constantly adding a number or I'm constantly subtracting a number. But we always call it a common difference, whether it's positive or negative. The way that we find that common difference is by subtracting a term minus the term just before it. So in example 1, we're asked to determine the common difference and then find the next 4 terms. So I do negative 98 minus negative 129, because that's what's going to tell me my common difference. And in our calculator, negative 98 plus 129 is 31. So that means I'm constantly adding 31 in order to find my next term. So negative 67 plus 31 is negative 36. Add another 31 and I've got negative 5. Add another 31 and I've got positive 26. Add another 31 and I've got 57. For part B, in order to find the common difference, that's 187 minus 244. And that's negative 57. And that means that I'm constantly subtracting 57 in order to find my next term. So the problem was also asking us to find the next 4 terms. 130 minus 57 is 73. Subtract 57 from that, and that gives us 16. Subtract 57 from that, we have negative 41, and we subtract 57 from that, we have negative 98. I mentioned in the last video that once we are specifically studying arithmetic sequences or geometric sequences, we will have formulas that allow us to find a specific term without dealing with a recursive formula. So in example 2, they're asking us for an explicit formula. This is kind of the pattern that we use in order to write an explicit formula. However, in order to write this explicit formula, we need to know what the value of d is. So the value of d is 23 minus 35. So that's negative 12. And now I have everything I need in order to find my explicit formula, which is a sub n equals, my a sub 1 was 35, plus n minus 1 times my common difference of negative 12. That's my explicit formula. Recursively, if I'm defining this sequence recursively or with a recursive formula, what I'm doing is referring to my last term. Well, we talked back here about how what I'm doing in order to find my next term is applying my common difference. So that's what we would do here. My a sub n could be expressed as a sub n minus 1 minus 12, because my common difference was negative 12. So now we're finding the nth term in a sequence, and it's a whole lot easier when I have this formula. So in this formula, I know what my a sub 1 is. I know which term I'm looking for, but I don't yet know my common difference. Well, that's easy to find. My common difference is negative 2 minus negative 29. So that gives me 27. And now I'm just going to apply the formula. A sub 38 will equal my a sub 1, which was negative 29, plus 38 minus 1 times 27. And then this is just order of operations from here. So 38 minus 1 is 37. I multiply that times 27, and then plus negative 29, and that's 970. In part B, this time I know what the 38th term is. I know what my first term is. I'm trying to find out what the common difference is. Once again, the formula becomes very useful to us. I know what my a sub 38 is. It's going to equal my a sub 1 plus 38 minus 1 times my common difference. And now I'm just going to substitute in these values. So this was 56.5. This was 75 plus 37d. And then we solve that equation just like you did in algebra a few years ago. Start by subtracting the 75. So we have negative 18.5 equals 37d. And when we divide both sides by 37, we find that our common difference is negative 0.5. If we know two terms of a sequence, but they're not consecutive terms, we can use that formula also to find the terms between them. Okay, so I know that a sequence has 6 arithmetic means between these two numbers. Okay, so visualize it. I've got 12.4, comma, 1, 2, 3, 4, 5, 6 terms, and then negative 24.7. Well, that means that this is my a sub 1, and this is my a sub 2, 3, 4, 5, 6, 7, 8. I need to find my common difference. So I know that my a sub 8 will equal my a sub 1 plus 8 minus 1 times that common difference. I substitute my values in and get negative 24.7 equals 12.4 plus 7d. And again, we solve this equation just like you did in algebra. I have negative 24.7 minus 12.4, giving me negative 37.1 equal to 7 times the common difference. So when I divide this by 7, I find that my common difference is negative 5.3. Well, that means in order to get each term in between here, I'm just going to subtract 5.3 from the previous term. So subtracting 5.3 from 12.4, I have 7.1. Subtracting 5.3 there, I have 1.8. So 1.8 minus 5.3 is negative 3.5 minus 5.3 is negative 8.8. Negative 14.1, negative 19.4, and I'm just going to subtract the 5.3 one more time just to make sure I didn't mess up somewhere along the way. And I get negative 24.7, which is this last term in my sequence. So we have found the 6th arithmetic means between 12.4 and negative 24.7. In the first lesson of this chapter, we talked about finding the summation or finding a series. An arithmetic series is naturally a sum of the terms of an arithmetic sequence. And we have two formulas that we can use for an arithmetic series, and it all depends on what information you have. In example 6, part A, I know what the first term is, I know what the last term is, I don't know how many terms there are, and I don't know my common difference. So let's figure out the easiest of those things. let's figure out our common difference. So that will be 193 minus 211, and that gives me negative 18. Okay, so I know what my common difference is, so can I use this formula? Well, I could if I knew how many terms there are. And since each formula requires that I know how many terms there are, I need to use the formula from back here. Once again, I need to use this formula in order to find out how many terms I'm dealing with. So I know negative 455 is my last term. I know that 211 is my first term. I know that it equals n minus 1 times my common difference of negative 18. So I need to solve this equation. So negative 455 equals 211 minus 18n plus 18 when I distribute this common difference of negative 18. Negative 455 equals 229 minus 18n. Solving this equation, I have negative 455 minus 229 divided by, finally, negative 18. And I know that there are 38 terms. Boy, this lesson likes 38 terms. And so now I can use this formula. So my sum of these 38 terms is 38 over 2 times 211 plus negative 455. So in our calculator, 211 minus 455 times 19, and that is negative 4,636. And this was all part A. Part B, I know how many terms there are. I know what my first term is, and I could very easily find my common difference. My common difference will be 23 minus negative 19. So that's 42. And now that I know my common difference, and I know how many terms I'm adding, and I know what my first term is, this formula actually presents itself as the easier formula to use. So S sub n, let's be precise, S sub 19 equals 19 over 2 times my first term times 2, so 2 times negative 19, plus 19 minus 1 times that common difference of 42. So I have 19 over 2 times negative 38 plus 18 times 42, which is negative 756. So order of operations, I have that 756 minus 38 times 19 halves, and that gives me 6821. Part C, I'm using this sigma notation, so I know what my first term is, or I can use the 23 for n and figure out what my first term is, figure out what my last term is, and I can subtract these values plus 1 in order to find out how many terms are in my summation. Okay, so A sub 23 is 2 times 23 is 46, plus 3 is 49. a sub 37 is, well, 2 times 37 is 74. 74 plus 3 is 77. So my n is 37 minus 23. That's the difference of these two numbers. But I have to add 1 to that. And if you've never noticed before, let me call it to your attention now. When I say do problems 1 through 10, you know that there are 10 problems. And perhaps you never even noticed that 10 minus 1 is 9. So you have to add the 1. Okay, so 37 minus 23 is 14, plus 1 is 15. Now I have all the information I need to plug into this formula for my summation. So my summation of those 15 terms, actually let's use their notation. So the sigma from 23 to 37 is going to equal 15 over 2 times 49 plus 77. So typing that into our calculator, we get 49 plus 77 times 15 halves, and that is 945. And I need a little bit more space. Actually, I can do part B up here. Okay, same exact idea. I can figure out what a sub 12 is by taking 12 and plugging it into the formula, or the explicit formula for the sequence. So I have negative 24 plus 57, that's 33. A sub 18 is negative 36 plus 57, and that's 21. My n is 18 minus 12 plus 1, so that's 7. And now I know that my summation from n equals 12 to 18 is going to equal 7 over 2 times 21 plus 33. So 21 plus 33 times 7 halves is 189.